Are you a podcaster? Maybe you've got that big idea and you're looking for a network to join. The multi-award-winning Ozcast Network can get your content to eyes and ears all over the world. Join now for the first month free, and you could be featuring this sound at the beginning of your podcast. Ozcast. Simply head to ozcastnetwork.com for details.
Professor Daniel Gray is with us on the line, I think. Professor, can you hear me?
I can, Jeremy.
Thank you very much for joining us. I've got Professor Ian Plimer here and Les Elekes at the dining room table. So you're talking to the three of us.
Excellent.
I wanted to talk to you about this Thymus research, which to me is absolutely fascinating. What made you start looking at it? It is connected to the fountain of youth in a way, is it?
In a way, yeah. Perhaps in terms of the immune system, that might be an appropriate way to think about it. The thymus is a really important organ that most people probably haven't heard of. It's just below the breastplate. It sits above the heart, and it's really important for the formation of the immune system. Over 60 years ago, a Weihai professor, Jacques Miller, discovered the function of the thymus. He found that it was important for making an important immune cell called a T cell. And T cells, they're essential for fighting off infections and cancer. And the thymus is the only place in the body where these T cells are made. So it's essential for proper health. But one of the weird things about the thymus is it kind of goes through an early retirement. So it peaks in function around puberty, but then swiftly begins to decline, so that in adults, the thymus is barely functioning at all anymore.
I can remember talking to somebody many years ago, and he was touring. He was on a world tour. He'd written a book, I think it was, and he had this catchphrase where, you know, if you are in need of a boost in energy, or you want to fight something off or someone off, you just thump your thymus. Now, is there any truth in that?
Well, in terms of the thymus having an important function in the immune system, that's true. But I'm not sure that thumping it is really quite the way to stimulate it. But in a way, that's what we're trying to learn. Is part of this research was trying to understand why the thymus should begin to shrivel up so early. It's the first organ in the body to undergo age-related decline. And so we want to learn why that happens so that we can reverse that process, so we can turn it around and restore immune function. And this is particularly important in certain immunosuppressed individuals, so people who might be receiving harsh cancer treatments, for instance. We know that they have a really tough time bringing their immune system back, and we would like to restore thymus function in those patients to improve their immunity.
How big is it?
It's at its peak, it's about 6 centimeters in length, and the structure is it's got two lobes, and it's about 3.5, 4 centimeters wide. But then it begins to shrivel up, as I mentioned, and so in adults it's replaced largely by fatty tissue, and it doesn't make many new T cells at all.
But you can live without it, but not as well.
Well, that's right. So it is true that most of us are healthy, even though the thymus reduces in function. However, it has been associated with poor immune function in old people. So, for instance, the recent pandemic, exposed that this was a very vulnerable part of the population. That's been linked to the fact that we're not making new T cells anymore, that the immune system's gone into memory mode now. But for sure, in these patients that receive harsh cancer treatments, the fact the thymus is no longer working so well means they can't get back those critical T cells. And this is strongly associated with their vulnerability to infection, which can cause, morbidity and mortality in that population.
Professor, I understand there's been quite a lot of work done since COVID commenced and treatments against COVID, and the realisation that vitamin D is a valuable supplement through sunlight and other supplementation to our immune system. And that seems to be becoming more and more significant in future immune deficiency issues.
Absolutely. Yeah, no, this is quite true. Vitamin D is a very active area of research to understand precisely what the mechanisms are by which it supports the immune system. Most of us are vitamin D deficient in some way or other. And so supplements can be important, but getting out in the sun is very important, of course. And there's also observations that there's a link between autoimmune conditions and vitamin D deficiency. So autoimmune diseases like type 1 diabetes, multiple sclerosis, these have been associated with deficiency in vitamin D, but no one quite knows what the causal link is. So at the moment, it's mostly association studies, but it's a really interesting area of research.
And vitamin D isn't a vitamin like C that actually resides in the body. It actually gets used up, so we need to continue to input it one way or the other.
Yeah, it's a very interesting biology, and then this activation by the sun is a really important part of its production as well. So there's a lot of interesting dimensions to it.
Do you think that the thymus, as you say, it shrivels up or shrinks? Is it designed to do that? Is it simply a process of nature?
That's a really excellent question, and we still don't know the answer, even though thymic involution's been known about for many, many years. Involution's another term we use for this shrinking. But the fact that we haven't been able to reverse it means that we can't really study what the consequences are. And there's some great ideas, though. It may be that it's important that the thymus shrivels up to perhaps conserve energy, because it's a very energy-intensive process to make T cells. Another idea is that there's a risk of continually making millions and millions of new T cells. Perhaps that could lead to leukemia or these autoimmune conditions I mentioned earlier. All these are quite plausible scenarios, but we just don't know the answer. And this is one of the reasons we're very keen to unlock the secret of how to reverse thymic involution so that we can restore T cell function, but also to learn why it is that the thymus involutes in the first place.
These little almost insignificant parts of our body, like the thymus gland, like the prostate gland,
or
like the
appendix.
thyroid gland, they all seem to be rather small pieces of our body, but incredibly important.
Absolutely, vitally important. Another one is the appendix, but now people are beginning to realize that although it's thought as this sort of vestigial thing, it actually can perform some really important functions, particularly after food poisoning, for instance, in restoring our gut microbiome and so forth after those sorts of episodes. So, yeah, it just goes to show that it's important to pay attention to these small but important parts of our body, and that there's a reason for most of it.
Because it used to be, when I was a young person, that the surgeons used to happily rip out an appendix or rip out tonsils. But nowadays,
adenoids,
and nowadays quite reluctant to do so because of the importance. They've recognised that they are there for a reason.
Yeah, absolutely. In fact, this is relevant to the thymus as well, because cardiac valve surgeries, which can be quite common and safe and really important, often they'll have to move or remove some of the thymic tissue. And I think there's a growing appreciation that it might be best to keep some of that because of this important immune function, especially early in life.
It's not like the liver where it kind of can regrow.
Oh, actually, it can regenerate. That's the really fascinating thing. And so we know from other research that there are ways to regenerate the thymus function, even in aged animals, but it's not a sustained regrowth. So while that's a way to make new T cells, it doesn't stay for very long. So this is part of the motivation for our research, is to understand what's going wrong inside the thymus so that we can reverse that process and cause thymic regeneration to be sustained.
And Professor, with one of the things we spoke about earlier in the program was the age of people and longevity and modern lifestyle and drugs, etc., making us live longer. But I did read and have researched that the body actually, once it reaches about 130 years, that's about the end of the trail no matter what you do.
Yes. Well, I think we're beginning to understand more about what the biological processes of aging, and particularly some of these molecular marks that we can now measure to understand, the effective biological age. And that's shedding an awful lot of light then on what the maximum is. Yeah, I'm fascinated to hear that number, actually. I wasn't aware of that. But I think increasingly the focus is on healthy aging, though. Yes. So extending life's a great idea, but we all want quality of life as well. Yeah. And that kind of brings us back to this question about immune function, because we know that susceptibility to infections can be a major drag. And so this is something we're keen to understand in more detail.
Yeah, we were also talking about this peanut allergy thing. Professor Rachel Peters from the Murdoch Children's Research Institute has connected up air pollution and the prevalence these days of so many people with peanut allergy.
Oh, right. Yes. Oh, well, it's a really important area there. I mean, in fact, in Australia, in Melbourne in particular, we're one of the allergy capitals of the world. So understanding how these factors come together and influence, and this is an immune reaction, again, the peanut allergy, how it is that we set up the stage through environment and genetics and other factors to cause these life-threatening responses is really important.
And Professor, in any of your work, are you looking at the issue of mental acuity, the degradation of our mental faculties, Alzheimer's?
Not part of my research program, but certainly here at WEHI in the Institute, there are active programs to try and understand early signs of neurodegenerative disorders like Alzheimer's disease so that we can detect them earlier and intervene earlier, because what we're learning is that the sooner you can detect disease, interventions will be able to delay or maybe even stop in time. So this is a really important and active area of research at WEHI.
I keep thinking of King Kong climbing the Empire State Building with Fay Ray under one arm and the King Kong thumping his thymus with his other fist.
Yes, and batting away the buzzing infections, if you like.
Indeed. Thank you, Daniel, very much for talking with us.
My pleasure. Thanks for your interest, Jeremy.
No, thank you. Very grateful that you came on the show. Professor Daniel Gray from the Walter and Eliza Hall Institute.
Are you a podcaster? Maybe you've got that big idea and you're looking for a network to join. The multi-award-winning Ozcast network can get your content to eyes and ears all over the world. Join now for the first month free, and you could be featuring this sound at the beginning of your podcast.
Ozcast.
Simply head to ozcastnetwork.com for details.